Okay, so in this video we're talking about linear inequalities in two variables. Before we've just been talking about linear inequalities in one variable. So this is going to be slightly different. And you can see here there's 4 different ways to write that. You can read on your own. But the most important thing here is that since we're talking about two variables for our inequalities, now a solution is going to be an ordered pair. And just like we saw with systems of equations, an ordered pair for a system of inequalities is an ordered pair that solves every inequality in our system. What we want to do now is check whether or not the ordered pair is a solution of 2x plus 3y greater than or equal to 5. We're going to check each of these ordered pairs by simply plugging in. Everywhere we see an x, plug in. Everywhere we see a y, plug in. It's supposed to be greater than or equal to 5. I'm going to do the first one in blue. So I have 2 times 0 plus 3 times 1. It's supposed to be greater than or equal to 5. Let's clear it up as much as we can. 2 times 0 is 0, plus 3 times 1, greater than or equal to 5. Well, 0 plus 3 is just 3. Greater than or equal to 5? I don't think so. This is not going to work, so unfortunately 0 and 1 is not a solution of this inequality. Same thing. Everywhere I see an x, everywhere I see a y. Plug in. 2 times 4 plus 3 times negative 1, greater than or equal to 5. I have 8 plus negative 3, greater than or equal to 5. 8 plus negative 3 is positive 5, greater than or equal to 5. This is true. 5 is greater than or equal to itself. In particular, it's equal to. So this one is a solution of the inequality. Then finally, for the last one, I have 2 times 2 plus 3 times 1 is supposed to be greater than or equal to 5. I have 4 plus 3 greater than or equal to 5. 4 plus 3 is 7, which is in fact greater than or equal to 5. So I have, out of these 3 ordered pairs, 2 of them were solutions of this inequality. So it's very easy to check. The graph of a linear inequality in two variables is the graph of all solutions of the inequality. Essentially what we need to do is graph the boundary line. If we see just less than or greater than, we're going to do a dotted line. If we see the line under it, we're going to do a solid line. Again, that's review. So in example 26, what we want to do is graph y less than negative 2 and x x less than or equal to negative 1. A couple things you need to realize is if you see y, that's a horizontal boundary line. If you see x, it's a vertical boundary line. It's kind of the opposite of what you would think. Again, y is horizontal, x is vertical. Okay? So the line y less than negative 2 means it's a horizontal line. I'm going just down to negative 2. I'm going to do this one in blue. Here's negative 2. And it's a horizontal line that goes through that. And I do not see a line under it, so I'm going to draw a dotted boundary line. And I suggest when you draw the graph, you actually write out the inequality beside it. Y less than negative 2. We want to shade to figure out which side we're going to shade on. We're going to pick a test point. The only thing about picking your test point is it cannot live on your boundary line. So I always try to pick as nice a point that I can pick that does not live on the boundary line. In particular, 0, 0. 0, 0 does not live on this boundary line, so I can test it. So what I'm going to do is say 0 is less than, I'm testing 0, 0. And what that means is I have 0 less than negative 2. All I'm doing is plug in. Everywhere I see an x, plug in a 0. Everywhere I see a y, plug in a 0 for this inequality. So I have 0 less than negative 2. Well, that's false. So I do not shade on this side where 0, 0 lives. So instead I shade on the other side. So all of this down here represents all possible solutions of that first inequality, y less than negative 2. Okay, and I'm just shading very messily, that's okay. My other inequality I'm going to do in red. It's less than or equal to negative 1. Again, since it's x, it's a vertical line, so I'm going to go to negative 1, and it's a vertical line. I see the line under it, so it's a solid boundary line. Again, I want to test a point that does not live on the boundary line. So again, 0, 0 does not live on this boundary line either, so I'm going to test 0, 0. You can test any point you want. I like 0, 0 because it's very easy to work with. Everywhere I see an x, I'm going to plug in a 0. Everywhere I see a y, I'm going to plug in a 0. So I end up with 0 less than or equal to negative 1. That's true. So I'm going to shade on the side that 0, 0 lives on, right here. So shade on this side. So everything on this side of the boundary line is a solution that will work for this red inequality. Okay, and that's how you graph linear inequalities in two variables. A very basic example. Step it up a little bit. Here I want to graph y less than 2x and 2x minus 5y greater than 10. Now, as soon as you have both variables, x and y, we can use the calculator to help us with our boundary line. The only thing is we got to make sure that y is by itself. Now, y is by itself here, so I'm going to graph this. I'm going to do this in green. So I'm going to just go y equals, clear out any other stuff that's here. Why is this erase? Go back to my pointer. I don't know why this is acting weird, but anyways, go to y equals, clear out all my other stuff that's here. I'm just saying y equals 2x. I'm pretending it's equals because that's what my boundary line is going to be. And there it is. So I know my boundary line is going to do something like that, but what I want are points, nice points. Let me go to the table. So this boundary line goes through 0, 0, and 1, let's say 2, 4. But here's 0, 0, and here is 2, 1, 2, 3, 4. So that's going to be my boundary line. And it's a dotted boundary line because there's no line under it, so I'm going to try to draw a straight line as best as I can. Again, it's just a sketch. Now what I would suggest is you also put the points you use on the graph so you remember. Again, write down the inequality so you see it on the picture, especially if you're doing everything in pencil. Now what I want to do is pick a nice test point. Again, the test point cannot be on the boundary line. Unfortunately, 0, 0 is on the boundary line this time, so I need to pick a different point. I want to just pick 1, 0. That's what I'm going to do. Test 1, 0. So everywhere I see an x, I'm plugging in a 1. Everywhere I see a y, I'm plugging in a 0. So I have 0 less than 2 times 1. Clean it up, so 0 is less than 2. That's true. So I'm going to shade on this side of the boundary line. So everything on this side of the boundary line is a solution to this inequality that's in green. Okay, great. Now what I want to do is to do my other inequality. I'm going to do that one in purple. But before I can do anything, I've got to get y by itself. So I need to do some scratching. I'm going to do that over here. I have to get y by itself before I can graph the boundary line. So I have 2x minus 5y greater than or equal to 10. I'm going to say minus 2x on both sides. So negative 5y is greater than or equal to 10 minus 2x. Now I have to divide by a negative. When you're talking about inequalities, and this is a rule you should remember, when we're talking about inequalities, if you multiply or divide both sides of the equation by a negative number, you have to flip the inequality. I'm dividing both sides of the inequality by negative 5, so I have to flip my symbol. So y is now less than or equal to 10 minus 2x over negative 5. There's more than one thing in my fraction, so I have to put in parentheses. Now I'm ready to graph. Let's bring my calculator over here. Go to y equals, clear it out. So you have to include the parentheses, otherwise this will not graph correctly. Divided by negative 5. Graph. That's what my boundary line is going to look like. So second table to find some nice points. I'm going to say 5, 0. I want the nicest points as possible. So 5, 0 is the y-intercept. 1, 2, 3, 4, 5. That's 5, 0. Go back to my table. And I also want to find the I found the x-intercept, and now I want to find the y-intercept, so at 0, negative 2. And now I want to draw my line connecting those to make my boundary line. It's going to be a solid line because I see the line underneath. So I'm going to do the best I can of a straight line. That was pretty close. Not great, but close enough. And now I want to pick a test point. This time, 0, 0 does not live on my boundary line. So I can test it. Everywhere I see an x, I'm going to put in a 0. Everywhere I see a y, I'm going to put in a 0. So I have 2 times 0 minus 5 times 0 is greater than or equal to 10. We'll have 0 greater than or equal to 10, which is false. 0, 0 lives on this side of the boundary line, so we do, since it's false, we do not shade on that side, so we shade on the opposite side. So that means everything on this side of the boundary line is a solution of the purple inequality. Okay, so we had a little bit more complicated example here. We had to get y by itself to graph it, but once we did, it's just a matter of picking a test point like we did before and shading. No big deal. A solution to a system of linear inequalities is an ordered pair that is a solution of each inequality in a symbol, and that's what I said at the beginning of this video. We want to graph this system. Fortunately here, both inequalities have y by itself, so we're going to just start like we did in the previous example, graph each boundary line, and shade each individual inequality. I'm going to do the top inequality in blue, the bottom inequality in green. I'm going to start with the top inequality. I'm just going to work with that one only. So go y equals, clear it out. Again, if y was not by itself, you would have to do the scratch work to get it by itself. Fortunately, I don't have to do any scratch work at all in this problem. Just plug it in. That's what my boundary line is going to look like. I see a solid line, so I know it's a solid boundary line. I'm going to go to the table now and pick some nice points. My y-intercept is 0, negative 1. I like the y-intercept, so that's what I'm going to do. 0, negative 1. Always write down what point you plug in. And then I'm going to try to find an x-intercept. Don't see it. Just trying to find nice points. Okay, well, I don't see a nice x-intercept with y equals 0. So what I want to say is, I've got 0, negative 1. Let's do, say, negative 2, 5. Just pick a nice point. Negative 2, 1, 2, 3, 4, 5. You can pick any 2 points that you want, but you have to have 2 points to draw a boundary line. Okay, again, it's a solid boundary line, so I'm going to try to draw a straight line between these two the best that I can. It's pretty terrible, but for our purposes, it's okay. I know for a fact that 0, 0 does not live on the boundary line. Here's 0, 0. So I'm going to test 0, 0. Again, I like to use 0, 0 whenever possible because that's the easiest one to use. So I'm plugging in only to the top one. Again, that's in blue. So 0 greater than or equal to negative 3 times 0 minus 1. So 0 is greater than or equal to negative 1. And that's true. That's my scratch rule. So since it's true on this side, I'm going to shade on this side of the inequality. Okay, great. Now I want to graph, again, only graphing the bottom inequality, and that's going to be in green. So I'm going to clear out all my other stuff. At x plus 2, graph it. That's what my boundary line is going to look like. It's going to be a dotted boundary line because I do not have a line under it. Go to my table and get some nice points. First one I'm going to graph is negative 2, 0. And another one I'm going to graph is 0, 2. And I'm going to draw a dotted line connecting those 2 points as best as I can. So something sort of like this, just a sketch. And again, 0, 0 is here. It does not live on my boundary line, so I can test it for the bottom inequality. So I have 0 less than or equal to 0 plus 2, which means 0 is less than or equal to 2. That's true. So I'm going to shade on this side of the inequality. Okay, again, very messy. Like I told you at the beginning of the semester, I really recommend you get some colored pencils if you don't already have some. And what the solution is, so the graph of the system is where these 2 graphs overlap. So where green overlaps blue. So it's actually going to be this piece of the graph right here. So this piece in red represents both inequalities working together. So that any point in this red area will solve the system because it solves both inequalities at the same time. Okay, I want to graph this system a little bit more complicated. We have 3 inequalities, no big deal. Again, I see x in a number, so that's a vertical line, y going to a number, so that's a horizontal line, and then x and y together, so that's going to be a diagonal line. X greater than or equal to 0, that's a fancy name for the y-axis. I see a line under it, so it's just the y-axis. That's pretty easy. And greater than or equal to 0, so greater than means go to the right. No big deal at all. Y greater than 0 is just a fancy name for the x-axis. I see a line underneath it, so it's a solid boundary line. Greater than means to go up in this case. So shading this side of the boundary line. And then finally, we want to graph our diagonal boundary line. I know it's diagonal because I see both x and y working together, but before I can do that, I have to get y by itself. So I'm going to do some scratch work over here on the side. 4x plus 3y less than or equal to 24. I'm going to start by subtracting 4x on both sides. So 3y less than or equal to 24 minus 4x divided by 3 on both sides. So I have y less than or equal to 24 minus 4x all over 3. Now, I have more than one thing on top of my fraction, so when I graph it, I have to put in parentheses, otherwise it will not come out correctly. So let's graph now. Put out anything else that's in there. Parentheses 24 minus 4x divided by 3. Okay, so that's what the boundary line is going to look like. I see a line underneath my inequality symbol, so I know it's a solid boundary line. It goes to the table, get some nice points. I'm going to do 0, 8, and 3, 4. So 0, 8, 1, 2, 3, 4, 5, 6, 7, 8. So 0, 8 is right here. And then I said 3, 4, so 1, 2, 3, 1, 2, 3, 4. Okay, and I know it's a solid boundary line, so I'm going to connect those two the best that I can. Kind of a curvy straight line, but again, for our purposes, it works all right. And I want to pick a point to test. Obviously, 0, 0 is right here. It does not live on our boundary line, so I can test it. So I'm going to test 0, 0 in the bottom inequality to figure out where to shade. So I have 4 times 0 plus 3 times 0 less than or equal to 24. 0 is less than or equal to 24 is true. So I'm going to shade on the same side that 0, 0 lives. So all it is on the other side of the purple boundary line will solve only the bottom inequality. Now to solve the system, I'm looking for where blue, purple, and green all overlap together. So I have from here to here to here. So I make a nice little triangle shape. So in this red triangle are all the ordered pairs that will satisfy all 3 inequalities of the system at the same time, which means these are the only solutions of the system in this red triangle. That's it for this video. This was review. A little messy with the drawings, but again, get you some color pencils, take your time, and I'm sure you can manage it. Let me know if you got questions.